All right, so this ed puzzle is about the exponent basics. So this sheet right here is going to be the sheet you reference all the time, all right, because it's gonna have all the rules that you are gonna need. So let's first start with what an exponent is. So before you get started, the big number is always gonna be called your base. And then the small number in the top right corner, this is your exponent or your power. These words are interchangeable, all right? Okay, so what we're gonna do is we're gonna fill out this chart here from the numbers 1 through 5 and the variable x using the exponents from 0 to 5. Now, it does not end at 5, it does not start at just 0, but this is the table we're gonna fill out, and you might have a pop quiz about this. All right, so in my calculator, if I wanna do this first one, if I wanna do 1 to the 0 power, I'm gonna type the number 1, and then this button right here, the one that is above the division sign, this button right here, this gives you the exponent, and I'm gonna put a 0 in there, and look at that, I get the number 1. Then I got 1 to the 1, so I got 1 exponent 1 gives me the number 1. Then I have 1 exponent 2, this gives me the answer of 1. Then I'm gonna have 1 exponent 3, and that gives me a 1. Then I get 1 exponent 4, and my answer is 1. Then I got 1 exponent 5, and what do you think that gives you? A 1. All right, now let's go to 2. So let's start with 2 to the 0 power. So we got 2 exponent 0, and we get a 1. Now we get 2 exponent 1, and we get the number 2. Okay, so now we're finally getting something different. Now we're gonna have 2 exponent 2, and that gives me the number 4. I want you guys to fill out the rest of the 2's. All right, so the rest goes 8, 16, 32. Now notice, every time you go up by a power in the number 2, you're multiplying by 2. Now let's go to 3. I want you guys to do all the 3's for me real quick. All right, so we start with 1, 3, 9, 27, 81, and 243. All right, now let's do the 4's. So start with 4 to the 0 and go all the way to 4 to the 5th. All right, 4 to the 0 is 1. 4 to the first power is 4. 4 squared, so if it's 2, it's 4 squared, is 16. 4 cubed, third power is cubed, that's 64. 4 to the 4th is 256. 4 to the 5th is 1024. Now let's do 5's. All right, so 5 to the 0 is 1. 5 to the 1 is 5. 5 squared, when it's a 2, you say squared. 5 squared is 25. 5 cubed, or 5 to the 3rd, means the same thing, is 125. 5 to the 4th, 625. 5 to the 5th, 3125. All right, so now let's deal with x's. So x to the 0 is gonna be a 1. X to the 1 is just a single x. Now notice, anything to the 1 power is just that base number here. All right, so every base number without an exponent technically has an exponent of 1, all right? X squared means x times x. X to the 3rd means x times x times x. What do you guys think x to the 4th is? X times x times x times x. What do you guys think x to the 5th is? X times x times x times x times x. Good job. All right, now for the rules, okay? So first we got this first basic rule. So we got the basic rules. We got what happens when you have a variable base and what happens when you got a number base. So this first rule here, these two different things, this where they're next to each other and this where we got the multiplication sign. This means we add the exponents. So same base and then the exponents get added together. Same base and it's being multiplied, the exponents get added together. So here, we're also multiplying. We just don't have that multiplication symbol there, and that's okay. That is gonna happen. Here, they actually have that little multiplication symbol here, the little multiplication dot, but you still gotta know that you are adding those exponents. So same base being multiplied, add the exponents. So same base being multiplied, x squared, x to the 3rd, add the exponents. So I'm still gonna have that base, but I'm gonna add the exponents. So 2 plus 3, so I'm gonna write that, 2 plus 3, that gives me 5. Then we got y to the 7th, shows me the times symbol, and then y to the 8th. So they're actually showing me this multiplication. So I'm still gonna have that same base y, but now I know that 7 plus 8 is 15. All right, now when I do a number base, same thing happens. I got same bases of 9. I got 9 squared and 9 to the 3rd power. These are technically being multiplied. So when I'm multiplying by the same base, keep that base, but add them exponents. So 2 plus 3 are the exponents, that gives me 5. 8 to the 7th and 8 times 8 to the 8th. All right, same bases of 8 being multiplied, so add those exponents. 7 plus 8 gives me 15, so we have 8 to the 15th. All right, so that's what happens when you multiply the same bases. You add the exponents, all right? And it doesn't matter if it's a variable base or a number base. All right, and the next one here, if we are dividing same bases, all right? If we are dividing either with a fraction bar or the actual division symbol, we subtract the exponents, all right? Same bases being divided, subtract the exponents. And you gotta be careful. The top exponent gets gets subtracted by the bottom exponent. So it'll be m minus n, that top number minus that bottom number. If you got the division symbol, the actual division sign, then it's gonna go that first exponent, m, minus that exponent n. So m minus n. So let's do some together. So we have a fraction bar, same bases happening. So that base is gonna stay, that's not gonna change. But I'm gonna do 6 minus 4, top minus bottom exponent, so I get z squared. Then I have j to the 27th divided by j to the 7th. Same bases being divided, so I subtract these. I do 27 minus 7, so that gives me j to the 20th power. The base does not change, only them exponents you gotta do the math for. Whether it's a number base too, same thing. So we got 10 to the 6th over 10 to the 4th. That base 10 stays there, but I'm gonna subtract these exponents. So that gives me 6 minus 4 is 10 squared. In your calculator, tell me, what is 10 squared? All right, then we have 7 to the 27th divided by, make that a division symbol, divided by 7 to the 7th. Same base is happening, but they're being divided, so I'm gonna subtract those exponents. So that gives me 7 to the 20th power. We are going to distribute exponents, AKA multiply. So just like before, all right? If there is a exponent on the outside of a parentheses, you distribute it to each of the exponents inside the parentheses. It does not matter if they have the same base. That exponent on the outside distributes to everything on the inside, all right? So let's do some together. So I got 3 different types we can have. We can have just one base, more than one base, or even if it's got that fraction bar, you still distribute, okay? So let's look at this. We got d to the 4th to the 3rd. All right, so that d is gonna stay there, but I'm gonna distribute this 3 to that 4. So 3 times 4 is 12. So we got d to the 12th power. Then we have ax to the 5th all squared. Well, see this a here? Now technically, there's a 1 on that a. All right, there's an exponent of 1, just like before. Any single number like this technically has an exponent of 1, all right? So I'm gonna distribute. So I have to do 2 times 1 and 2 times 5. So this gives me that base a becomes a squared, and that base x is now x to the 10th. All right, now we got c to the 12th all over r to the 13th. We distribute this 3 to the 12 and to that 13. So this gives me c to the 36th and c over r to the 39th power. All right, number base, same thing. That base 5 is gonna be there, but I'm gonna distribute this 3 to that 4, and that gives me 5 to the 12th. Then we have 2 times 3 to the 5th all squared. Now remember, this 2 has technically got a 1 to it, so you gotta be careful about that. 2 squared, distribute that 2 to the 1, so this gives me 2 to the 2nd power times base 3, 2 times 5, it gives me to the 10th power, all right? Do not distribute the exponent to the base. You're only distributing exponents to exponents, not to bases. Now I'm gonna distribute this 3 that's on the outside of the parentheses, so this gives me 1 to the 36th power, and then 4 to the 2nd power. 3 times 2 gives me 4 to the 6th power. All right, in the next row, this is the favorite row. This is the easiest row. Anything to the 0 power is 1. So g to the 0 power is 1. 1,000,001 to the 0 power is 1. All right, nothing crazy about that. Anything with a 0 power technically equals to 1. Is what happens if you have a negative exponent. So if you have a base with a negative exponent and it's a regular type of base with a negative exponent, it wants to move to the basement. So we're going to move it to the bottom of a fraction bar and make it positive. So it went from a negative m, move to the bottom and become a positive. Same thing happens in the other direction. If your base is at the bottom of a fraction bar and it's got a negative base, then it becomes normal, regular, not a fraction, base, and then to the positive n. All right, so I always think of it, if you're unhappy on the main floor, you move to the basement and now you're happy. If you're unhappy, you're negative. If you're happy, you're positive. If you are unhappy in the basement and you're feeling negative, move to the main floor and now you're happy, now you're positive. All right, so let's look at this. We got b to the negative 2. So this negative 2 means you're unhappy. So we're going to move to the basement, move the base to the basement, and change that exponent to a positive. We have 1 over e to the negative 21. It's feeling negative in the basement here, so I'm going to make it regular sized, or regular, and it's going to be to the positive 21 exponent. Same thing happens with a number base. 16 to the negative 2. All right, unhappy on the main floor, so it's going to move to the basement. So that base is going to move to that basement, and it becomes positive again in the exponent. 1 over 30 to the negative 21. Feeling unhappy in the basement, move to that main floor, and now your exponent is positive. So we have 30 to the 21st power. So keep this with you. Let's move on to the next side. So we're just rewriting it in expanded form and shrinking it to exponent form. So 2 to the 3rd means 2 times 2 times 2. X to the 5th means x times x times x times x times x. Negative 4 to the 3rd power. Now see how negatives, they have to be in a parentheses in order to have an exponent next to them. So just be careful of that. Negative 4 times negative 4 times negative 4. Then there's some challenge problems for you. And then we're going to take these expanded forms and write them as exponents. So if I have 7 times 7 times 7, I'm going to have 7 to the 3rd because there's 3 7s there. I have negative 8, and I have 1, 2, 3, 4 of them. So that's going to be negative 8 to the 4th power. Then I have y's. So I have all these y's, and I have 1, 2, 3, 4, 5, 6 of them being multiplied. So I have y to the 6th. And then we have some challenge problems. So if you have any questions, feel free to ask your teacher, but the rest of this sheet is all you.